Hi everyone, Assalamualaikum warahmatullahi ta'ala wabarakatuh. Today I would like to present a topic about maintenance system titled Sound Vibration Signal Enhancement for bearing fault detection by using adaptive filter, which is we compare between adaptive noise cancelling filter and adaptive line enhancer filter. So as you know, the defect machine components can be detected based on the changing of the signal characteristics. However, the change of signal characteristic from the defect machine component is difficult to be detected. So because the defect signal usually will be corrupted by other signals called noise or also known as unwanted signals. Therefore, these unwanted signal needs to be removed. There are many methods that can be used to filter out the noise signal or unwanted signal. We can use fixed filter, but the problem is fixed filter we need to determine the unwanted signal range frequency. We can also use blind source separation, but the thing is blind source separation assume that each source signal is statistically independent. However, in the actual application, all the component or machine part is connected each other, hence the signal will influence each other. So basically they are dependent. So we can move to the additive filter. Additive filter is kind of the improved version of better blind source separation, and it uses a single source signal as a reference signal. But the thing is, this, the current additive filter use a single source signal. So the single source signal may provide only partial information that can be obtained due to inherent limitations of sensor that have varying degrees of uncertainty. Hence, multiple sensors believe can improve the signal enhancement. So in this project, we set up a fault simulator device. We use two sensors, vibration sensors and microphone sensor to capture the sound signals. So the sensors will collect the vibration signal and sound signal and collected by data acquisition model. So these signals then loaded to the computer, and by using MATLAB software we use to develop the algorithm of ANC and LE to compare which one is more efficient to remove the unwanted signal. So basically, theoretically, the additive filter is a well-known algorithm and reliable technique that able to remove unwanted signals without need to know the characteristic of unwanted signal. This is because additive filter automatically will adjust the filter coefficient based on reference signals that highly correlate with the unwanted signal that mix with signal. So the coefficient correlation is based on minimum square error algorithm of the additive filter output. So basically the lower MSE value, so the unwanted signal will be closer to reference signal. Hence, based on this reference signal, adaptive filter will reiterate adjust the coefficient filter until the MSE is minimal. So in this work, two types of algorithm will be used, which are additive noise cancelling filter and additive light enhancer filter. So the way we interpret the data, we to determine which filter is more accurate based on this epsilon value. The scale of optimum filter is known between range 0 to 1. So if epsilon 0 is 0, so the additive filter with the optimum value filter coefficient has perfectly eliminated the unwanted signal. So in this project, we use two approaches, simulation and experimental work. So we use simulation to evaluate our algorithms, and then we proceed with experiments. So in based on this simulation signal, we have the, create a synthetic signal. Okay, as you see at your left is the signal that been filtered by using ANC filter, and the right one is the signal that's been classified or cleaned or filtered out by using ALE filter. So this one, the left one, the figure, this is figure one, from top is the actual considered as a actual signal, and then we mix up with other signal. and then we filter it out by using ANC filter, and then we get our signal back. But this one using ANC filter. And the right one, the same thing, we create the signal and then we mix with other signals, so it produces at this graph, and then we filter out by using ALE filter, so that the outputs we can get the back our actual. So based on the observation of this time waveform, both ANC and ALE filter can remove the unwanted signal. So the way which one is better based on this absolute value, based on the simulation work, we can see the ALE filter is more efficient compared to ANC based on this epsilon value, because ALE is 0.0014, is closer to the zero. Okay, and then we move to the next simulation. We create a signal that mixed with noise signal. So this one, the left one is ANC signal, ANC filter, and the right one is ALE filter. So as you can see, but this one is the actual signal, and then we mix up with the noise signal, so it's saying the signal is being corrupted. Okay, and then we use ANC filter to filter out the noise, and finally we get our signal back, okay, as shown in this one. Okay, and the same thing goes for ALE filter. We create the signal and then we mix up with the noise, and then we filter out by using ALE filter, so that we get back our actual signal. Okay, based on this epsilon value, it seems, yeah, ALE filter is more efficient compared to the ANC. Okay, so at this stage, we believe that both filters can eliminate or remove the unwanted signal. So we move to the actual signal. So this one is based experimental work. The left one is based on vibration signal, and the right one is the sound signal. Okay, the thing is, as you can see from the left one, this is a distorted vibration signal. Okay, distorted vibration, which means a corrupted one, where the signal is being mixed with our component, the defect component. So by using the additive noise cancelling filter out, so we can see the signals, the ripple and this time waveform signal is being removed. The same thing goes for the ALE filter out. Okay, so basically both ANC and ALE filter can filter out unwanted signal. Okay, but and then the same thing goes for the sound signal. So this at 7A, okay, this one is signal is being mixed with the noise. Okay, we can see the peak somehow mixed with the very noisy signal, and then we filter out by using ANC and ALE filter. As you can see, this here is the filter signal by using ANC, and this here is filter out signal by using ALE filter. So generally, both filters can remove the unwanted signal. And in terms of efficiency, in experimental work, is shown somehow ANC is much better, better than ALE filter. The same thing goes for the sound signal. Okay, so conclusions: two type of additive filter by using ANC and ALE has been used to classify the signal of interest from mixed signals. So generally, the simulation and experimental work show that both additive filters succeed to classify the defect signal from the mixed signal. However, based on the least mean square error, ANC filter is more accurate than ALE in experimental work. So this probably the reference input used in ANC has many signal components correlated in mixed signal due to noise source at the machine body bar. So even though the LE filter is less accurate than ANC, the ALE filter is more practically to apply in a real environment of fault detection applications, since ALE filter no need the reference signal, which is hard to obtain in actual complex machine. So we believe for moving forward, we need to continue to investigate the effectiveness of ALE and NC at various frequency, and to analyze the other signal processing techniques such as FFT or spectrogram and many more, so that we can obtain more accurate results. So that's all for today. Thanks for listening.